On this computer. Hi, hello guys, good afternoon. So, ayan. Crap. Nangyari. Lah, ayan. So, ayan siya. So, ayan yung topic natin for this week, integration of trigonometric functions. Pero before tayo mag-proceed doon, before tayo mag-proceed sa mismong mga formulas of integrals natin or integrations, discuss muna natin yung tinatawag nating trigonometric identities, okay? Or trigonometric, ang kapal. Trigonometric identities. Okay. So, better way to understand or to learn about trigonometric identities is using this hexagon. Okay? So, siguro, ewan ko kung na-discuss na sa inyo to before, kung na-discuss na sa inyo nung high school, nung senior high, or nung college, ewan ko kung saan part pwede siyang i-discuss, pero ayun. Di-discuss natin itong trigonometric identities. Paano nga ba itong sinasabi to? So, yung trigonometric identities natin, guys, ibig sabihin, kahit anong gawin nyo dun sa identity na yon, kahit anong gawin yung pag-ikot-ikot dun sa identity na yon, it always be true. Okay? True or truthful yung identity na yon. Okay? So, yun yung na-explain dito. So, meron tayong 3 sets of identity. Okay? So, first set of identity is yung mga inverted triangle dito. So, ang hanap dito yung mga inverted triangle muna. Okay? So, ito yung first set natin. First set. So, pakita natin dito. First is yung tinatawag natin na Pythagorean. Pythagorean. Wala ako spelling. Wait lang. Shucks. Hindi ako sure anong spelling ng Pythagorean. Nalito ako bigla. Pita. Ayan. Tama. Okay. Pythagorean identities. Ano nga ba yung Pythagorean identities muna? 'Di ba? Kung naalala niyo pa si Pythagoras or yun nga, in-explain niya dito yung relationship between the legs of a right triangle. So, bago tayo mag-proceed doon, discuss ko muna kung ano yung Pythagorean theorem, 'di ba? Yun nga, Pythagorean theorem. Pythagorean theorem. Anyway, so Pythagorean theorem, ano nga ba 'yon? It says that the squares of the legs, so example, we have right triangle here. So we have right triangle here. So yan, sabihin right triangle siya. You say that this is B, and so we say itong dalawang ito yung legs, while this one we call this hypotenuse. So sinasabi sa Pythagorean identity theorem na that the sum of the squares of both legs is equal to the square of the hypotenuse. So yan yung ina-explain sa Pythagorean identities natin. So guys, so itong Pythagorean identities natin, pwede natin siyang magamit or ma-apply dito sa trigonometric identities natin. Paano natin makikita yung Pythagorean identities dito? Pythagorean identities, makikita natin siya dito through inverted triangle. So ito yon. Hi Magsanay, what are you doing here? So, ayan. Ito yung tatlong inverted triangle natin. Sige, at pwede ka naman umaten, huwag ka na mag-leave. Okay lang yan. Okay? So, we have here, ito yung tatawag ko ngayon na inverted triangle. So, pag inverted triangle, ibig sabihin, nasa baba, yung apex niya. Okay? Yan yung mga apex natin. And of course, this one is the legs. Diba? So, and this one. So, ayan yung straight line defines yung legs. Tinatawag natin na legs or bases na tawag. And yung circle is yung apex na tinatawag natin. So, dito sa Pythagorean identities, it states that the sum of the squares of the bases is equal to the square of the apex. So, yun yung Pythagorean identities natin. Okay? So, urahin natin to. So, ayun yun yung first set of identity natin, yung tinatawag na Pythagorean identity. So, based dito, ito yung tatlong natin. So, first triangle, itong nasa tataas. So, balik tayo doon. So, magiging sine squared theta plus cosine squared theta is equal to 1 squared or 1 na lang. Okay lang yon, parehas lang yon. Okay? So, ganyan yung setup for our first set of identities. So, the same dito sa isa. So, tangent squared theta plus 1 is equals to secant squared theta. And then 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, so ayan yun. Yan yung first set of identity na tinatawag natin. Okay, next identity tayo. So, nagigets na. Nagigets nyo naman siguro yung first set natin, di ba? So, next set of identity tayo, guys, is yung tinatawag natin na reciprocal identity or reciprocating identity. So, paano ngayon yung reciprocating identity? So, ito siya. Pakita natin. Anong kulay na lang. Ayan. So, second, reciprocating identities. Or reciprocal. Reciprocal identity. Okay? Identities. So, itong reciprocal identity natin, ito yung mga diagonal lines sa loob ng hexagon natin. Okay? Ano yung diagonal lines? It connects two opposite, ano 'di ba? Yun yung diagonal natin. It connects two opposite points. So, example, this one. Yan. And this one. And of course, ayan din. Okay? So, ano ngayon yung reciprocating, ano ngayon itong reciprocal identity natin? It states that, so, mangyayari, paano ba yung reciprocal? So, yung ano dito, ibig sabihin yan, yung ito is equal to the ratio or to the ratio of 1 over this one. Ganon. Or vice versa. Paano vice versa? So, we can now say sine theta is equal to 1 over cosecant theta. Or, we can also say cosecant theta is equal to 1 over sine theta. And so on. So, ganun yun. Sine, tsaka cosecant, cosine, tsaka secant, tangent, and then cotangent. Okay? Ito ngayon yung reciprocal identity natin. So, dagdag natin. Cosine theta is equals to 1 over secant theta. And then, lastly, secant theta is equals to 1 over cosine theta. Tapos, tan theta is equals to 1 over cotangent theta. And then, cotangent theta is equals to 1 over tangent theta. So, ayun na yung second set of identity natin, guys. So, I hope nakaka-follow through pa kayo. Last identity natin, so last identity is what we call ratio identity. Okay? So, pwede siyang tawagin na ratio identity. So, third, ratio identity. Okay? Or identities. Yan pala. Ayan. So, ngayon, paano natin isa-solve itong ratio identity? So, technically, actually, pwede tayong magawa ng apat eh. Pero, yun. Sige, pakita natin yung apat na yun. So, ito, ibig sabihin, ganyan yung magiging setup ng ratio identity natin. Okay? Ganyan siya. So, tapos tayo yung arrow. Yung arrow ng kung paano yung, so, ganito mangyari. Sin theta over cosine theta is equal to tan theta. Ganyan yung setup niya. Okay? So, connect na lang din natin. So, ganyan din. So, dito naman, cosecant theta over secant theta is equals to cotangent theta. Okay? So, ganyan yung niya. So, ito yung ratio identity na tinatawag ko ngayon. Tangent theta is equals to sine theta all over cosine theta. And then, cotangent theta is equals to cosecant theta over secant theta. So, katulad ng sabi ko kanina, guys, pwedeng apat yan. So, it works like this. Ganyan. So, ito naman yung second set natin. Ibang kulay na lang gamitin ko. I hope na follow through nyo pa siya. So, ito. Cosecant theta over secant theta is equals to cotangent theta. Okay? So, ganyan din. So, ganyan siya. Okay? So, sulat natin. Cotangent theta is equals to cosine theta over sine theta. Although, itong identity na to, pwede siyang ma-derive, okay? Pero, pwede siyang ma-derive and then, pwede rin siyang makita sa hexagon natin mismo, okay? So, ganun din. So, next is, paano na yan? Magiging secant theta over cosecant theta is equals to tangent theta. Okay? So, ganyan naman yung setup nila. So, tangent theta is equals to secant theta over cosecant theta. So, ito ngayon yung three sets of identities natin. Okay? I hope nagigets nyo. So, ayan yung three sets of identities natin. So, technically, guys, kahit anong gawin nyo sa identity na yan, it always be true. Okay? Kahit na ang gawing, example, paano sinasabing it always be true? Example is yung identity natin sa Pythagorean. Kahit na ang gawin nyo dito, kahit na ang gawin nyo dyan is maging sine squared theta is equals to 1 minus cosine squared theta, true pa rin yan. Kahit anong gawin nyo, true pa rin yan. And of course, cosine squared theta is equals to 1 minus sine squared theta. So, and so on. So, ganun din dito. Okay? Is equals to secant squared theta minus 1. 1 is equals to secant squared theta minus tan squared theta. Okay? So, ganito din dito. 1 is equals to secant squared theta minus cotangent squared theta. Oh, and cotangent squared theta is equals to cosecant squared theta minus 1. Okay? So, ngayon, yan yung ano natin. Yan yung ano natin, guys. So, technically, paano siya nagiging applicable? So, mostly, ayan yung ano natin, yung mga Pythagorean, ito na yung mga trigonometric identities natin. Itong nasa page 2. All of these are trigonometric identities. So, di ko na di-discuss ngayon. Actually, meron pa tayong tinatawag na half angle, double angle na tinatawag, mga ganong identity. Pero, no need siguro for me to discuss it. Okay na yan. Okay? So, dagdag natin, guys, is yung tinatawag natin na SOHCAHTOA. Anyone knows or remembers their trigonometry? Na-discuss ba to nung high school kayo or anything, di ba? So, actually, mahaba yan. Hindi lang yung SOHCAHTOA. SOHCAHTOA, tsaka Kausha-cho pa nga actually. Kausha-cho. Pero okay na yan. Kasi guys, pagdating sa trigonometric identities, hanggat maaari, i-reduce natin siya. So, technically, meron tayong 6 na trigonometric functions, diba? Meron tayong 6, sine, cosine, tangent, cotangent, and cosecant, and then secant. Pero technically, as much as possible, dapat ma-reduce lang natin dito sa tatlong to. Dapat ma-reduce lang natin yung function natin into these 3, dito sa tatlong to. Sa sine, sa cosine, sa tangent. Technically, dalawa nga lang eh. Kasi, pwede na namang sine and cosine na lang. So, yun yung ano natin. Pero dito papasok ngayon, yung proving identities tayo mamaya. So, discuss muna natin ano tong SOHCAHTOA. Technically, nagiging useful ang trigonometric functions sa pagkuha ng angle. Okay? Application. Ano mga pwedeng application ng angle natin, guys? Example, sa mga gusto magpiloto. Kung may mga gusto magpiloto sa inyo, technically, sobrang halaga ng angle. Okay? Dalawa yan. Either angle of elevation or take-off angle or landing angle, approach landing, approach angle, anything you want to call it. Okay? So, it boils down to 2, technically. Hindi ko masasabing tama ko, pero feel free to correct it. It boils down to 2, which is the angle of elevation and angle of depression na tinatawag natin. Okay? So, paano nga ba natin nakukuha yung angle? Pwede natin makuha yung angle through trigonometric function. So, dito ngayon papasok yung na-discuss ko kanina na right triangle. Di ba? So, example, we have here a right triangle. So, and, kuwari ito yung angle natin. So, ayan yung angle natin. Okay? So, ayan. So, if yan yung angle natin, kung yan yung angle natin, ibig sabihin, itong side na malapit sa kanya or kadikit niya, we can call it as adjacent. Yun yung ibig sabihin ng adjacent actually. Adjacent means yung kadikit niya or yung malapit sa kanya. And of course, yung malayo sa kanya is malayo din sa angle So ito guys, yung itong adjacent at saka opposite, depende yan kung nasaan yung angle na meron ka. Okay? It depends kung nasaan yung angle. Example, kung meron kang another drawing. So ito. Ito, may another, right triangle ka. Kung dito yung angle mo. Of course, ito na yung magiging adjacent mo. And while this one is your opposite. Okay? Pero syempre, pagdating dito, unspoken rule tayo when it comes to getting angle, lalo na magagamit nyo to sa engineering mechanics, even though hindi na ako yung maging prof nyo doon, di ba? At least medyo may pwede akong ibigay sa inyo once na nag-engineering mechanics kayo. So technically, ang unspoken rule when it comes to getting angle, it always must be on the horizontal axis. Okay? So we call this as horizontal axis and then vertical axis. So we can also call this as x-axis, x and y axis na tinatawag. So of course, ayan na. So technically, this one, we call this opposite. Okay? And of course, the opposite of the right angle is always be the hypotenuse. So, dyan napapasok ngayon yung SOHCAHTOA natin. Okay. To getting angle, so sin theta, depende kung anong meron ang given. So, depends on your problem. Sin theta is equals to opposite over hypotenuse. Okay. And we have also cosine theta is equals to adjacent over hypotenuse. And then, tan theta is equals to opposite over adjacent. Okay? So, madalas nagagamit to sa natin. Okay, dagdag application nito, guys, lalo na sa mga gustong magpiloto. Okay? Is yung pagkuha ng bearing or pagkuha ng direction. Okay? Nagagamit siya sa pagkuha ng direction natin or ng bearing or displacement na tinatawag. Okay? So, sobrang helpful dito, lalo na itong tan theta, kasi mostly, depende, ang given lang is opposite and then adjacent. Okay? So, technically, it's, kung mapapansin nyo, itong adjacent natin, we can call this as x-coordinate, opposite as y-coordinate, yun lang. And then, tangent theta is ito na yung mismong angle natin. Okay? So, dyan, pwede natin maging application yung SOHCAHTOA natin, or yung trigonometric functions tinatawag. Okay? Pero kung more on other application pala na sa integration, siguro sa higher maths na yon, higher maths, higher physics, ganun. Okay? So, ayan. Muna. Teka. Okay, so balik tayo dito. Hindi ko na i-discuss siguro kung paano na-convert tong cosecant theta o tong cotangent into cosine theta over sine theta. Kasi pwede ko naman siyang i-convert. Sige, pakita ko na lang din. Just in case. Converting, paano ba to? So another topic to Para lang. Kasi, pagdating sa identities or sa trigonometric identities, as much as possible, i-reduce natin siya into two trigonometric functions, which is yung sine and cosine natin. So, converting cosecant theta over secant theta, yung ba yun? Tama. To cosine theta over sine theta. Actually, madali lang naman yan. Okay? So, bago natin siya gawin, tandaan nyo tong reciprocal identity natin. So, we have here cosecant theta is equals to 1 over sine theta. And then, secant theta is equals to 1 over cosine theta. Okay, so gagamitin natin yan. So, ayan. So, we have here, katulad sabi ko, cosecant theta is equals to 1 over sine theta. And then, last is yung secant theta is equals to 1 over cosine theta. So, technically, substitute na natin itong 1 over sine theta, pwede siyang i-substitute dyan. And also, itong 1 over cosine theta, pwede natin siyang i-substitute. So, mangyayari na is magiging 1 over sine theta all over 1 over cosine theta. So, technically, mukha siyang complex fraction ngayon. So, kung complex fraction siya, multiply lang natin yan and then multiply din natin yan. So, magiging kalabasan ay magiging cosine theta over sine theta. Okay, so ngayon, that's how you convert. So, ganyan yung proving kung paano natin nagawa na yung cotangent theta is equal also to cosine theta over sine theta. Okay? So, ayan yon. So, ayan siya. So, kaya ko rin siya na-discuss, guys, kasi kailangan natin siya, magagamit din natin siya when it comes to integration. Okay? So, huwag kayong mabahala. Hindi ko siya tinuro na basta gusto ko lang. Okay? Kailangan niya yan. Okay? So, practice tayo para ma-gets niyo kung paano siya ginagamit. Oh my God. Ano na kagad? Ay, kala ko ano na. So, ayun. Okay, so next, ano tayo? Practice tayo sa paggamit ng trigonometric identities. Okay? Teka.